Hello, welcome to the Module 6, Blockchain Systems Architecture and Consensus Protocols. In this module, we will have 4 lectures. And in this lecture, in the first lecture, we will explore basics in blockchain system architecture. The main learning outcome of this module is to learn how to construct architecture of blockchain-based applications, apply design patterns, compare different consensus protocols. The main learning outcome of this lecture is to explain fundamental design and architectural primitives of the distributed ledger systems architectures. The content of this lecture is as follows. We will speak about the distributed ledger and distributed ledger technology first. Then we will speak about the blockchain architecture components, and then we will analyze blockchain types. We will finish this lecture with the blockchain reference model. Let's start with the first item, and let's look into the distributed ledger and distributed ledger technology. And let's first of all understand what is the difference between the central ledger and the distributed ledger. Central ledgers are physical books or digital files used by individuals or organizations to record and total economic transactions in a centralized manner. Traditionally, a central ledger is managed by the accounting department of the business to record all economic activity that the company is involved in for the purpose of financial analysis, tax reporting, and more. Hence, all parties reconcile the local databases with the centralized electronic ledger that is maintained and controlled by a trusted central party. Although efficient, this approach has disadvantages. It relies on a central authority to manage all bookkeeping, and it makes the ledger vulnerable to any mistakes made by that authority, either deliberate or accidental. Distributed ledger refers to an approach to recording and sharing data across multiple data stores or ledgers. This approach allows for transactions and data to be recorded, shared, and synchronized across a distributed network of different network participants. A blockchain is a particular type of data structure used in some distributed ledgers, which are stored and transmits data in packages called blocks that are connected to each other in a digital chain. Blockchains employ cryptographic and algorithmic methods to record and synchronize data across a network in an immutable manner. As the linear chain grows, when the new blocks are added, earlier blocks cannot retrospectively be altered to any network members. And what are the features of the blockchain, of the distributed ledger? The distributed ledger allows self-interested participants in a peer-to-peer network to collectively record verified data in a shared ledger without relying on a trusted central party. The removal of the central party can increase speed and remove cost and inefficiencies associated with maintaining the ledger and subsequent reconciliations. It can also enhance security because there is no longer a single point of attack in the entire network. Systems that support distributed ledger feature many nodes that reach a consensus when processing transactions. Because of that decentralized and redundant nature, there is no single point of failure, and this reduces the vulnerability that attackers would tamper the stored data. In distributed ledger, once a record goes into the chain, it can't be changed. This means there is one confirmed client record of the event. All the data stored in the ledger is viewable by all parties, so there is built-in transparency that stakeholders find useful. With this distributed ledger, regulators can get in the loop and continuously monitor risk with real-time ledger access. With native encryption, hashing, and key-based schemas, it provides a high level of security and privacy of information stored in it. Digitization of assets is a process in which the rights to get an asset are converted into a digital token on a blockchain. Ownership rights are transmitted and traded on a digital platform, and the real-world assets of the blockchain are represented by digital tokens. Due to the lack of intermediaries, verification process are speeded up. A multi-level monitoring mechanism ensures that the third party is not needed. Absence of intermediaries and the high level of automation reduce operational cost of transactions. But what is distributed ledger technology and how it can support distributed ledger? Indeed, distributed ledger is supported by the use of the distributed ledger technology. This is a technology that allows for transactions and data be recorded, shared, and synchronized across a distributed network of nodes using cryptographic tools and a distributed consensus process in an immutable manner. Distributed ledger technology is a technology that reinvents the way people trade and conduct transactions. A distributed ledger is a database that is synchronized and accessible across different sites and geographies by multiple participants. The need for a central authority to keep a check against manipulation is eliminated using a distributed ledger. Underlying distributed ledger is the same technology that is used by blockchain, which Bitcoin uses as a distributed ledger. A distributed ledger can be described as a ledger of any transactions or contracts maintained in a centralized form across different locations and peoples. Cyber attacks and financial frauds are reduced using distributed ledgers. Distributed ledger technology can potentially destroy existing business models by refusing mediation, but it has no infrastructure cost. There is no need to support servers or system administrators, which drastically reduces the cost of creating and running decentralized applications. It also reduces transaction cost and data redundancy and simplifies document management and minimizes manual labor. It also protects the ledger with the controlled mutability and tamper appearance. How does blockchain-based distributed ledger technology work? Let's assume the following case. Let's assume that we have a case where A creates new transaction block with the transaction from A to B. Blockchain-based distributed ledger technology systems take the form of the append-only chain on the data blocks. The new additions are initiated by one of the members, nodes, who creates a new block of the data containing several transaction records. Information about this new block is then shared across the entire network, containing encrypted data, so transaction details are not made public. All network participants collectively determine the block's validity across to a predefined consensus mechanism. Only after validation, participants add the new block to their respective ledgers. Through this mechanism, each change to the ledger is replicated across the entire network, and each member has a full identical copy of the entire ledger at any point of time. Blockchain can be understood through different layers. And in this situation, we have explicitly defined these different layers. The first and the bottom layer of the multi-layered distributed ledger technology stack would be the network layer. This layer consists of the peer-to-peer network in which participants share resources without a central authority. So it means it is decentralized. The network layer is critical and takes care of peer discovery, transactions, and the block propagation. Depending on the size of the blockchain, the speed of the peer discovery, network delays, and propagation may have the impact on the performance of the distributed ledger technology. The consensus layer is very important in the distributed ledger technology state system, as its role is to get all the nodes of the system to reach an agreement. The data layer of the blockchain is typically used to describe the physical layer of the blockchain or distributed ledger technology. This includes data block and the main structure, hash function, Merkle tree, asymmetric public key data encryption, and timestamp technology. Despite all of this technology included within the data layer, the most important aspect of this layer is storing data. The data layer is the blockchain's database and safely stores all information in the form of data blocks. These data blocks, which are formed into the chains, can be accessed by any full node. The execution layer has a runtime environment such as virtual machines, containers, and compilers that are installed on nodes. This layer also implements smart contracts through which it implements trust. Finally, the application layer is the top layer of the blockchain network and is used to connect decentralized applications with the underlying blockchain technology. Next, let's speak about the key blockchain architecture components. So what are the key blockchain architecture components? Ledger is a collection of data or transactions. Transactions are described how an asset transfers onto or off the ledger. Nodes are network participants in a distributed ledger network. Contract describes conditions for transaction to occur. Peer-to-peer network is a decentralized distributed network of nodes that stores, updates, and maintains a distributed ledger. Distributed ledger is based on a consensus and describes principle of replicated, shared, and synchronized digital data, which is geographically spread across multiple nodes. When exploring the blockchain platform, it is important to understand that each node in the network maintains its own copy of the ledger, and it is the job of the network to come to a consensus on how the ledger contents is updated. Security is guaranteed by the cryptographic technology, which is employed in the blockchain. It ensures the integrity of transactions. There are blockchains that contain transactions or bundles of transactions. Each new block is linked to the previous one in a cryptographic chain in a way that the data can't be altered. Consensus mechanism is the important aspect of the blockchain design, as it is used for checking transactions' integrity in the decentralized manner. In order to participate in the network, the blockchain requires permission. Open source client can connect to the network in the public blockchain. The ledger copy is provided once the network has completed the necessary synchronization. Participants in the permissioned blockchain must be granted permission before they may join the network. Both peer-to-peer networking and the internet are covered by this permissions policy. The network's participants benefit from the privacy provided in the blockchain. This means that the network should be designed in a way that confidentially anonymity is guaranteed by protecting the transactions and identities of participating nodes. It should be satisfied that an unauthorized third party is not able to identify the counterparties to a transaction in a blockchain, and transaction details is not visible to the person who is not involved in that particular transaction. Every member of the blockchain network has a generated addresses, not a user ID. This preserves the anonymity of users, especially in the public blockchains. When considering the blockchain network, it is important to understand the following components. Participant types. Participant parts of the network and endorsed transactions, network service providers, network service consumers, business service providers, business service consumers, end users. They are all individuals. They may have different roles. Network roles are assigned to participants. They may include network services, which are the foundational blockchain network services such as the peer-to-peer network, smart contract, execution containers, and security services. Business services are the blockchain application built on the underlying network services, such as the smart contract logic, the client-side application logic that connects to the blockchain, and any integration logic with external system. Assets are either purely digital or backed by a physical object, as an asset represented something that is recorded on the blockchain. The asset may be shared across the whole network or can be kept private depending on the network and on the requirements. A smart contract defines the asset. Transaction is the interaction points between the assets and the participants. A participant can create, delete, and update a given asset, assuming they are authorized to do so. The transactions that are stored immutably on the blockchain, which also provides the provenance of any changes to the asset over time. Transactions are coded inside the smart contracts alongside the assets to which the transaction belongs. Endorsement. Endorsements are performed by one or more organizations on the network for each transaction submitted. Endorsement policies can be defined both at the smart contract level and for the individual states written to the blockchain ledger. Deployment. Deployment describes the way on how blockchain network can be deployed across a heterogeneous environment. For instance, the network could be within a single cloud environment or premises or a hybrid of the two. Network access. Network access describe the access permissions. For instance, how the access policy between the different network components will be defined so that these components be able to communicate. Regulations. Regulations such as the European Union General Data Protection Regulation may influence your design and architecture of the blockchain network. Non-functional requirements such as transaction latency, transaction per second, and volume of the data should be confirmed as early as possible. What are security considerations? Security features in the blockchain technology much rely on the cryptographic principles. For instance, an asymmetric encryption scheme uses two sets of keys, a public key that is widely disseminated and a private key that is only known to the owner. Public key cryptography can be used to create digital signatures and is used in a wide array of applications, such as HTTPS Internet Protocol for authentication in critical applications and also in a chip-based payment card. Other security considerations include decisions regarding private keys, where and how private keys will be stored for each of the components in the network, are hardware security modules a requirement. Also regarding certified authorities, are these certified authorities that are required to issue certificates for organization in the network. Also regarding encryption, what other transport level security is required by participants interacting with the blockchain network. Also regarding privacy and confidentiality. Is there a requirement for privacy and confidentiality of data, identity, and transactions stored in the blockchain? Now let's look to the different blockchain types. Public blockchains. Blockchain systems can be classified based on the decentralization and transparency properties and the speed of transactions. More specifically, we can separate between the private and public, between the permissioned and permissionless blockchains. Public permissioned blockchain allows applications to be developed in production or removed without having to notify anyone, reveal the identity, or meet any application criteria requirements. The nodes which constitutes the network and run set applications must be invited to join the network. Public permissioned blockchain is the most decentralized. Applications can be deployed in the production or removed without having to notify anyone, reveal the identity, or meet any application criteria requirements. Additionally, the nodes which constitute the network can freely and anonymously join and contribute, typically in an exchange for the network's native cryptocurrency. Other part are private blockchains. Private permissioned blockchain offers no decentralization. The applications and the network nodes running those applications must both be invited to join the network and meet certain criteria or provide a form of identification. Any party can also be removed without warning at any time. Private permissionless blockchain requires that applications deployed in the production be invited to join the network and can be removed without warning at any time. The nodes which constitute the network and run said applications can freely and anonymously join and contribute, typically in exchange for a network's native cryptocurrency. In permissioned distributed ledger, each node in a peer-to-peer network owns a full and up-to-date copy of the entire ledger. Every proposed local addition to the network by the network participant is communicated across the network to all nodes. Nodes collectively validate the changes through an algorithmic consensus mechanism. After validation is accepted, the new addition is added to all respective ledgers to ensure data consistency across the entire network. In permissioned distributed ledger, nodes need permission from a centralized entity to access the network and make changes to the ledger. Access controls can include identity verification. How to recognize what type of ledger is used by business? This simple schema can help. If there is only one ledger, most probably the traditional ledger is maintained by the central party. If many copies of the ledger are managed, one needs to estimate who can access and use those copies. If only one trusted group of the network participants use it, most probably it is the permissioned private ledger. If the copies are used by anyone, one needs to check who maintains the integrity of the ledger. If only one set of trusted network participants can validate it, then permissioned public ledger is used. If anyone without needs to trust can manage it based on consensus mechanism, then the permissionless ledger is used. A comparison between both public open blockchains and permissioned blockchains is given in this table. It analyzes along the central party, access, level of trust, openness, security, speed, identity, consensus, asset, and illegal ownership criteria. To finalize the comparison, potentially you can analyze 2 permissionless blockchain and Ethereum and 3 permissioned blockchains as illustrated in this table. But now let's look into the blockchain reference framework and let's understand what are the key parts, what are the key components of the blockchain technology. Reference model for the blockchain technology consists of 6 major components: actors and their roles, services and processes for network discovery, transaction, consensus, and blockchain generation. There are 2 main roles like user and block generator. User is an actor who acts with the blockchain by creating transactions. Block generator is a human or system actor responsible for validation of transactions, building new blocks, signing new blocks, and broadcasting new blocks to the blockchain. This actor can also provide consensus to support trust between the parties involved, proof of work, proof of stake, and other. Service components, which display the services used by the actors to interact with the technology. Services are transaction creation, transaction submission, block validation, block generation, block access. Transaction creation allows users to add information to the blockchain. Transactions can be used to create assets, spend assets, create smart contracts, call functions on the smart contracts, manage permissions. Transaction submission supports signing and broadcasting the transactions to the network. Block validation is the general service used by the nodes to validate the newest blocks that have been added to the block. Block generation is broken down into smaller services that are used differently depending on the type of consensus. A miner in the public blockchain would use the block generation services, but in a chain core, one party creates the block and other party signs the block. Finally, blockchain access is a specific type to private and permissioned blockchains where administrative nodes can grant access to known parties. It can also be used to create network tokens for nodes. The reference model includes 4 processes: network discovery process, transaction process, consensus process, and block generation process. Network discovery process consists of 4 sub-processes: peer discovery, handshake, discovering additional peers, and synchronization. Process begins by acquiring an IP of the known peer of a blockchain. IP is known from the last session or is acquired from the outside source. Once connected, private blockchains will perform a check if the user is allowed to connect via its public IP or in a network token. If permitted, a handshake process is carried out to verify permissions and check that both nodes have the same blockchain with the latest blocks. Next, the connected node's IP will be propagated to the network. Once the network is discovered, the connecting node will synchronize its blockchain if any difference in terms of the latest blockchain is observed. Transaction process starts creation of new transaction. Relevant metadata are added depending on the transaction type. For example, data transfer of funds, creating assets, deploying smart contracts, and other. In the case of private blockchains, there will be the permission check, whether the specific user is permitted to create the transaction, whether the receiver is permitted to receive funds, whether the network permits transfer of funds or creation of specific type of transactions, etc. If the transaction is permitted, or in case of public blockchains the creator signs the transaction, it will be broadcasted to the network, means to the neighboring nodes. Consensus process is performed by each node when a new block has been broadcasted. Each blockchain defines its own consensus rules, according to the type of the validated blocks and transactions. If validated, the nodes will append to the new block to the blockchain otherwise it will be rejected. During the blockchain generation process, first a new block is generated. Next, the previous block metadata is added. In case of the permission blockchains, permission changes have to be applied in order to avoid unwanted permission performed by the user who do not have permission. Next, all transactions will be validated against the consensus rules on the blockchain. In public blockchains, the block generator, means miner, will provide the proof of the work and will be rewarded for the work. In private blockchains, the consensus process might be part of the block generation process. Once the block is constructed, it is submitted to the network and propagated to all nodes. The data model shows that keeping the state of the blockchain is preferred here in comparison to the input-output type transaction logic. State contains accounts which have balance and address. In case of contracts, they also have to keep the executable code and store specific to the given account. Accounts are linked to the transactions and each transaction changes in the state of the blockchain. Balances change, contracts function calls, and others. Block and block header are standard and essential to every blockchain platform. Block contains transactions. The block metadata is kept in the block header. This summarizes our first lecture, where we have looked into the principles of the distributed ledger and also defined the features, analyzed the features of the distributed ledger technology. Then we looked into the components of the blockchain architecture and saw the differences between the key blockchain types. In the end, we also looked into the blockchain reference model. Thank you for your attention.